6.3, number 39. Jane Adele deposits $500 in an account at the beginning of each 3-month period for 9 years. If the account pays interest at a rate of 8% compounded quarterly, how much will she have in her account after 9 years? So, all right. So information that's known is you got a payment of $500. It's at the beginning of the 3-month period, so the beginning of the quarter. So that's going to be an annuity due. And time period is 9 years. And if the account pays interest, how much will she? So it pays 8% interest. And the compounding is quarterly. So that means there are 4 periods there. And it's asking for future value, and this is unknown. Because it's asking how much is going to be in the account after 9 years. Okay. So, the interest rate is 0.8% annual. We want the period interest, so that's going to be 2% because we divide 8% by 4. So 0.02. We need to know the number of periods, so that's going to be 9 times 4, 36. And we know the payment, we don't know the future value, and this is an annuity due. So the formula we're going to be using is future value is payment times this growth factor, and then because it's an annuity due, we have this extra interest that's earned. So, again, that's the growth factor. Okay, so we no payment, period, interest. So, and this is, we're trying to find the future value. So we just need to plug the numbers in and calculate it. Again, this is the growth factor, and it's going to be enhanced a bit by this extra interest because it's an annuity due. So 500 times 1 plus 0.02 to the 36 minus 1, 0.02, and times 1 plus 0.02. Okay, so 500, that's our payment. This is going to be 1.02 to the 36 minus 1 over 0.02 times 1.02. Okay. So 1.02 to the 36 is roughly 2.03. Again, keep all the decimals in the internal calculation. 0.2. Okay, so subtract 1. That gives us 1.39. Stuff with 0.02 times 1.02. Okay, so let's do it. All right, so divided by our period interest is this 51.9 times 1.02, and then times our payments. So again, this is an annuity due, so the actual growth term is this. So it's 53.03, keep the decimals, times 500, times 500. So that gives 26,517.27. Okay, and at this stage, you now round it to give 26,517 and 13 cents. one point I want to make is if you had forgotten this extra growth from the annuity due, you actually end up with a smaller amount. And in this one, it's enough to make a difference, it is, as you'll see. So if you had neglected to do this computation, you would end up with 25.9. So if this is missing, so say it was an ordinary, you end up with that, and you'll notice that this amount here, just by putting it in an extra period, or at the beginning of the period, sorry, you end up growing by more than one of the initial payments. So you get an extra 500 plus on this. So just making the deposit sooner into the account earns you more money in the long run. So that's important to be aware of.